Now see the refraction through glass prism, and thus we can understand the lateral displacement taken by the glass prism. First of all, what is a glass prism? A glass prism is a rectangular block which is made of glass. Glass is a transparent material. We know that when light is entering through the material, it can pass through it and it can emerges out in the same medium. In which medium it is coming, from which medium it is incidented, in the same medium it can be emerged also. So here glass prism is in the rectangular shape. So now let us see the glass prism shape. This is a rectangular glass prism which is in the shape of a block. So this is a glass prism. This glass prism I will draw as a rectangle only here. So when light enters through the glass prism, if you take a single light ray, a light ray is incidented by making an angle with the normal. This is incident ray. Incident ray is incidented here. Where the point of incidence, at that point of incidence I will draw a normal here. So this is angle of incidence. And here when it enters into the glass slab, slightly it bends towards the normal. Why? Because this is air, this is glass slab. So light ray enters from rarer medium. Air is rarer than the glass. So light enters from rarer medium to denser medium. When it enters to denser medium, its velocity decreases. When velocity decreases, it is attracted towards the normal. So here this is the angle of refraction. Angle of incidence, this is angle of refraction. So again when it enters into the glass slab, it travels in a straight line. Why? Because same medium, light travels in straight line. But when it comes here the medium changes again. This is glass, this side it is air. So when it enters here, again slightly bends. But here if you draw a normal here, this is angle of incidence. When this light enters from glass to air, means denser medium to rarer medium. When it enters to rarer medium, what happens? Velocity increases. So when velocity increases, it moves away from the normal. So it moves away like this. So this is the emerged ray. See that this is the incident ray, this is the refracted ray, this is also refracted ray, but it comes out. That is why we can call it as emerged ray. This is emerged ray. This is refracted ray. This is incident ray. The incident ray is making an angle with the normal. So this is angle of incidence. Angle of incidence. Here this is angle of refraction. Angle of refraction. Here this is angle of incidence again. This is also angle of incidence. When it comes here, it takes refraction. This is also angle of refraction, but it is coming out. That is why it is considered as angle of emergence. It is also angle of refraction, but we can call it as angle of emergence. See here how many times the light ray refracted? 2 times the light ray refracted. This is here 1 time and here 1 time. So through the glass slab, if light passes, it refracts 2 times. So if you extend the incident ray, if you imagine that this glass slab is not here, the light ray passes in a straight line. If you extend the light ray like this, then you can see that this is the emerged ray, this is the incident ray. There is some perpendicular distance between these two. This is the perpendicular distance. This perpendicular distance is called as lateral displacement. The perpendicular distance between the extended incident ray and the emergent ray is known as lateral displacement. So when light ray passes through the glass prism, the lateral displacement you can observe here. So if angle of incidence increases, what happens? The angle of emergence also increases. Why? Because this is also in air, this is also in air. So how much, with what angle of incidence here incidenting? With the same angle of incidence, angle of refraction, it emerges out. If the angle of incidence is 90 degrees, what happens? If the angle of incidence is 90 degrees, the light ray cannot refract it, straightly it passes. Why? Because it is passing through the normal. So the angle of incidence is 0. Yeah, if angle of incidence is 0, it cannot take any refraction, it will not bend. So through the glass slab, it is a condition, if you don't want to get refraction through the glass slab, only when the light is incidented with 90 degrees with the glass slab, then you cannot get any refraction. So straight line. Other than 90 degrees, if you incident with making an angle with the normal, then you can get refraction 2 times. It can get refracted 2 times. And another thing is, if the glass slab thickness increases, the angle of emergence also, means lateral displacement also increases. If thickness increases, this angle of refraction, if you extend the light ray, this lateral displacement also increases. So based on this, questions will come. Okay.